Okay. Okay. Hello, everyone. So, as our workshop is going to begin today, so first I will try to introduce a basic of Google Earth Engine, how to get started, and very basic things which are absolutely required. And then I will go into the shoreline extraction, how we can extract the shoreline from the Google Earth Engine automatically. Let me share my screen. Okay, someone please can confirm the screen and my voice is clear.
Yes, sir, skin is visible.
Okay, sure. This is nothing but the YouTube video of Google Earth. What basically we can do through the Google Earth engine. Many of you must have seen it. Just for a basic introduction, let us see the video. So as it says, we need to create an account first of all. I guess many of you don't have the account as well. And for instruction, I sent a PDF, but the thing is they have changed the some interfaces and some we can say some steps in the account. So if anyone from here would like to volunteer who don't have an account and share his or her screen, so I can say the step like code dot we need to go to code.earthengine.google.com, right? As I enter, point is my you can see the screen. It is already opened. The thing is that my account is already created. So as at the beginning interface, I cannot show here. One thing what I can do is I can show you how to register a new cloud project. But for the first time, who will be signing in, that interface I cannot show from here. So for that, if someone who don't have an account can volunteer and share his or her screen, anyone? Okay, so I will stop sharing, and Professor Ram Kolapkar will share his screen, and I will mm, guide you. Please.
Is my screen is visible?
Absolutely.
Okay, so
Everyone, please
from
follow him.
where should I
Start
start?
doing right now. You can open a new tab and type code dot earth
Oh,
engine
Earth
dot
in
google dot com. Google.com. Yeah, that way.
okay, I'll again type it.
Sure. Earth engine spelling is something is
Okay,
wrong with Earth
I'll
engine.
copy this site from here
Okay,
and
yeah, yeah. Sure, you can copy that. You can cut that one.
so should I select one account out of this?
Yeah, that should be any Gmail account. You should select an Gmail account,
Okay,
not institute email
okay.
shouldn't
I'll
you want.
select one of my Gmail account for and
Okay, sure.
continue with that. Okay,
So this will be the screen for the first time user. Whenever you go to the website code.earthengine.google.com, here will be your first time, I can say, interface. Here you need to click on I want to register a new project. So please click on new project. So this type of interface will come up,
okay,
and from you can see there in the right hand side there is a create project option.
here.
Click on the create project. Okay. So this will be here. You need to specify your project name, whichever name you like to prefer. Maybe let's say coastal or coast. Anything you like to do it. I guess your Google is opened in I mean say your institute email. Just select no organization. Yeah, this will be the thing.
So no organization should be selected.
Yeah,
Okay.
and we go to the location browser. Is there anything that is? You just select the no organization. There is nothing that just cancel it. Cancel it. Can you just click on your account name in the right hand bar? Is it
Here,
your organization? Yeah, this need to be changed.
should I change it?
Yeah, yeah, this will be the interface.
Okay.
So project name, you can just keep by project name, or you can choose the default name. The default name will be there.
Here,
Project name,
project.
you give a project name like post, and there is a small thing you can see just under project name, project ID. There is a default project ID, and which will be required particularly, especially, and you can edit it. Just click on edit. just under project name, there is a project ID. Yes, you can change the project ID. This is what we require to run the Google Earth Engine thing, particularly. So
May
here
I
we need to
change this
specify a
postal
project
project
ID.
ID?
Sorry.
Can I change this project ID also?
Absolutely, absolutely. You can change it, anything. Maybe your name or anything. Okay, just you can just click on create.
Okay. Uh, okay, okay. It should be lowercase.
Okay, lowercase. So here you need to now you need to activate the account. Your project has been created, but you need to activate the account. So here is the two option you can see. One is for register for commercial use, and next one is for non-commercial use. So we'll go for the non-commercial use. So we can click on the get started in non-commercial use. Yes, get started. Okay, here you can just specify your organization. What type of organization? You can select as per your interest. For particularly, we can here see the public or private academic institution. We can go with that. Or if you are engaging with any other thing, you can do that. So click on the next. So here you need to specify your institution, academic institution. Just specify any academic institution you have been working with, maybe. And next, here you need to select no. That is, you are not, I mean, you don't want commercial use. So you need to click no, and this option will be coming scientific or decision making. I guess everyone will be here is specifying scientific research, or you can use decision making as well. That doesn't matter. And you need to just keep any your research question as it is star mark. It is, I mean, say, I mean, required. So, for example, for this purpose, for we can say it's shoreline analysis. Just we can write our research question as shoreline analysis, for example. And next, we need to select global or regional. If we select regional, we need to specify a region. So for that purpose, just select global. So no need to. And next, have you used any Earth Engine topic before or not? So you can select no, doesn't matter. And click on check eligibility. Okay, so that will be show you are eligible for non-commercial use, and go to next. Pricing plan, no need. So next. So particularly what type of work will be this will, I mean, say, mm, try to focus on. Three option is there. You need to select any one of them. Maybe mitigation, for example, or protection or conservation. Doesn't matter as well.
We can
Maybe
select
both.
multiple also, no?
Huh?
We
Sorry.
can select multiple also here.
Absolutely, absolutely. We can select multiple as well. And from the drop down, you need to select any of the thing, whichever suits you. And if anything doesn't suits you, there is the others option in the at the bottom of the list, or you can select any one or multiple as well. For example,
Okay.
just for this purpose, maybe you can just select for time being others, or maybe that there is option for scientific research and thing was there that you can select as well. Maybe scientific research and development. Maybe
Yes, it is there.
okay, you can okay. That is up to the user what they want to select.
Yes,
This
yes.
is not so. Yeah. And click on OK. Okay, I guess others, you should check off the others. If you are check on others, so you need to specify other. So you need to, I mean, no need to go for
I'll
another step. Just check off
uncheck
the
it.
other. Is will you? Yes. Okay, go. Now click on next and click on register. Okay, another. So it is showing you are now registered for non-commercial use, and you can just click on continue to get the overview. Just click on the continue. That overview will come up, and in the Earth Engine code editor, you can just go to the previous, say previous tab where there is Earth Engine code editor. Previous tab in the Chrome tab, Earth Engine
Yeah.
left one. Yes, just refresh this. You can just refresh this one on time. You can see uh, this is still not showing. So click on yes.
Which one?
I authorized yes. So you have already created. From the drop down, you should see the your project.
There's
I
no
will.
listing.
Okay, just go back to the last tab. Welcome to Earth Engine again. Just double click on the coastal. Just beside Google Cloud, there is a your project name coastal is there in the left side.
Yes.
Just click on project is created. No issues. I guess your both the Gmail account are same.
Uh,
Say the Gmail account you used here for creating the project, and the Gmail account you have used it during Art Engine code editor,
yes. Both
which
are
is
same.
same.
Both are same.
Both.
Sir,
Uh,
sorry for the interruption. I have done all these things, and you can directly go to code editor from the overview tab.
Go to the new tab in the Chrome, Google Chrome, and there you write. Go to the website again, codeartengine.google.com. It is still not showing.
Hello, am I audible?
Yes, yes.
Sir, sorry for the interruption. Actually, I have also done the same procedure in morning. So he can directly go to code editor from the overview. Come to the welcome to Art Engine tab. Yes, close this one. Yeah, drag to the below. Expand your experience. Yeah, no. Before that, expand your yeah. Use the code editor. You can click that code editor.
yeah.
Yeah.
Okay. Yeah, that was helpful. Thank you.
Thank you, sir.
Okay. So you can now stop sharing. This was the thing.
Okay.
Uh, so your account is created. So as your account is created, you can see your code editor is like this, and here the coding in JavaScript. But particularly, we're not going to continue the session in JavaScript. We are going for the Python. As you have already seen in the video, there is the two type of thing we can in two way in JavaScript and Python. And during the course, I will say I will give many instances why we are preferring Python over JavaScript as well. So one thing you need to note down, or you can take it see from here as well in the code editor. Your the project ID particularly will be visible here. For me, that is Jyotirmoy 100. Okay. This thing will be required in Python. Okay. So for Python, what we will do, we will go for the Google Colab. So what we can do, this is my Google Drive. You can go to your Google Drive. Okay. And you can see in the upper left corner, there is a plus sign and called new. If you just click on that and expand for more, there will be option called Google Collaboratory. And for the first time, who haven't used Google Colab or Google Collaboratory, I mean, say before, this option wouldn't be there for them. So what you need to do, you can click on plus connect more apps. When you click on plus connect more apps, a window will come up, and from here in the top search bar, you can search collab and select the collaborator. Okay. There will be an option, this type of symbol, this collaboratory. As it is installed for me, you can just double click or click on that, and there will be an install option for you, those who are doing for the first time. Okay. If you just click on this install, the Google Collaborative will be installed within seconds. This doesn't take time. And after installing, you can just close the window and again go to the plus sign, expand more, and this Google Collaborative option will open up. Okay. So if you just click on Google Collaboratory, a new window will come up of Google Colab, which in short we say Google Colab. This is nothing but the notebook where we'll write the code. As we have seen in the code editor, this is a JavaScript. In the Python, Colab, and this will be its interface. For the beginning, people usually prefer to JavaScript code editor because it is kind of, you can see this is kind of interactive. There is a map, there is a content panel, there is a something else, and there is a code editor. And here we can see there is a default map view, or we can say normal toposheet view, topographical map view, and there is a satellite view. You can change the map view from here. But on demerit is that when you open the Google Colab or work with Python, interface will be like this, blank. Mostly, there is something command is there. One thing particularly to open up, and you can use you can add multiple code block like this and delete as well. So first thing first, what we need to do, we need to first import two Python library. What are those Python libraries and how do we import? We say import EE. EE is for Earth Engine. So whatever Earth Engine command is there in the, you can say in the code editor as well. If you just go into the left panel and in the docs section, you can see there are many more algorithms is there, all that is start with EE, mainly Earth Engine. These are stored in this Python library. If we are working in Python, these are stored in this Python library. And so we need to import EE. So how can we run? There is a run button. You can just click on that. And you can see the network is connecting for the first time when you are running. This will be connecting. And as it connected, you can import the EE. And here is the main thing. You can use another code block to import another library. We'll use this two library that is called GE map. What is GE map will do and what is it? As in the code editor, you can see there is a map. So to work with the map, we are using another library that is GE map, which will visualize our map and many more things as well. So primary thing is to visualize the map over here. So as we say, you can just click on this run button to run this cell or the code, or you can use, you can see there is a prompt as well. You can enter control plus enter. If you just enter from the keyboard control plus enter, the cell will run. Okay. It is not like that you need to take different code blocks for each and every code. For example, same code can be written in the same code block in different languages. For our convenience, we create different code blocks. So this is the step which we need to do in Python, and we don't need to do in the JavaScript. That is, one thing is EE dot, we need to authenticate. Authenticate is nothing but to give permission to your Google Drive or Google account, the Google account that will, use. So I will just run it and some pop-up will come up. You need to just allow these notebooks to use Google credential. So you need to allow, you need to select your Gmail account. And for the first time user, whoever using for the first time, there will be some terms and condition and three or four checkbox, I guess, in this window. So you need to, for those, you need to check on those box and then click on continue. As I have already done previously, so that checkbox is not there for me. So as you continue, I guess this step or previous step
Excuse me, sir.
that you need to check. Yes.
Sorry to interrupt you. Just can you repeat the last two stages again after GEE map?
Okay, sure. So as you import the two libraries, and two libraries is for EE is for Earth Engine commands. Whatever command we will use to retrieve images and do analysis or many more things, that commands is stored in the EE library. And GE map to visualize the map, basically primarily, and we can do many more things as well using GE map library. So we need to import these two things, and then we need to authenticate your uh, Google account. You need to give access to your Google account. So for that, you need to run this code EE dot authenticate. A is capital. If you just run this code, you need to allow, and a pop-up window will come up. Here you need to select your Gmail account. Click on your Gmail account, and in this window, or maybe after clicking continue, in this window there will be, for the first time user, there will be 3-4 terms and condition checkbox. You need to click on that. As I have already done, so those option is not there for me. Just make sure you check on those and click continue, and your authentication will be completed. You can do all the things in the same code block as well. For the simplicity, I am taking the different code block. And another thing you need to do is initialize. You can see one thing. You can here only can differentiate two things in the Python. Whenever I am writing here in the Python, just I have written e.I. There is many options which I can select from that. You just no need to remember whole the spelling as well. There will be many more options. You can just select it. And here within initialize what we do, here we specify our project. Okay. So here within the bracket, you need to write project equal to, within quotation, your project name. What is your project name? Sorry, project, particularly not project name, project ID, which will be this one. In the code editor as well, you can see my project name is this one. Okay, you can have different project ID. So for this, I am taking this project ID, and you need to specify that one. And run it. So we are done. We are done with importing and initializing, authenticating the Google Earth Engine. So basically what difference we see here, we are interactively seeing something. Here there is nothing to see. So first of all, we will see a map. How to see a map in Google Color. So for that, we will define a variable. Another difference you can see, whenever you are defining variable in JavaScript, for example, we are defining a variable called var map is equal to something we will write. So in the JavaScript, we always write var before defining a variable. In Python, you no need to do that. You can just write the variable, let's say we are writing map, capital M, you can write anything. And equal to what we need to do, the library we have imported, ge map dot map with M capital. This contains the default base map for the visualization. We have defined this here a base map in the variable map, and we'll just call in the next line map. Okay, and just run the cell. You can see there will a map will come up. This this is the map that has been came. I will just briefly explain some of the uh, tools that is there. One of the basic difference we can see in the map window, upper top right corner, there is an option called toolbar. If you can just click on that, there is the fourth option. You can see there's called change base map. Just click on this and you can see a drop down, and there is many more options of base map. In JavaScript, we have C, only map and satellite, these two. But here you can take different base map as your interest. Maybe say if we just take a satellite image, these things will come up. There are many more options is there. You can in your spare time you can check it out. We will use one of the option called inspector in the later stage of this course. So let us keep with our satellite image. And in the left panel, there is called search option. I am coming to that. Plus and minus, you know that, zoom in, zoom out. And this there is an option called full screen view. Particularly, this option doesn't work in Google Colab. But if we are working with different environment, let's say Jupyter Notebook, this option will work. If you just click, I am just clicking, this doesn't work. One thing for I mean say full screen, there is an drop down just under the run cell. If you just click on that, view full screen output. If you just click on that, this half screen type of full screen is there. So this full screen thing doesn't work good in Google Colab, as I say. And there is the drawing tool. One is the marker or simply point, rectangle, polygon, and line. Okay, I will use in the later stage how to draw that, and we will draw as well. And there is a search. We can search a place by name or address. Let's say if we are taking about for the location we will be using for the Medinipur coast in the West Bengal coast, particularly you can say we will be focusing on today for the shoreline extraction. And there is a place called Mondarmuni. Just type and enter. The location will there will be a marker in the location, search location. And on the thing is that in the this type of satellite image there is no name. So for naming purposes, you can change the base map from here and go to a default to see the names of things. So this is the Mondarmuni beaches which we'll be working with. Similarly, you can use lat-long, and there is a data search. You can check it out in your own, but we are not going to use that for today's early session. From where we need to get the data or data ID particularly, we'll see that. So I'm going to just delete this search location. So we are here. You can just zoom into your location as well, particularly no issues with that. So first thing, what we will do, we will define our region of interest. Okay, for which region we want to work with. Let's say as our interest is coastal, so we are interested in this coast part of this beach. You can apply it anywhere, no issues. And for that, I will take the polygon option, just single click, and there will be plus cursor, just left click from just left click. How many points you want and how to finish. You can click on this finish to finish, or you can just click on the first point to finish. Your drawing is finished, but this is only your Earth Engine not yet recognize you this geometry. One thing you need to understand that these are all geometry, particularly not vector. I guess you understand the difference between vectors and geometry. So vectors will be geometry plus attributes. So this is just only the geometry part. And to, uh, I mean, store in a variable, let's say we are storing in a variable ROI, short form for reason of interest, or you can name anything. And we want to store this geometry which we have drawn in the variable ROI. For that, we will use map dot user underscore ROI. That is also already there. We can just select it and run it. Your geometry variable is already stored in this ROI. Okay. Now, if you want to delete it, you can delete it from here as well. Okay. Or you can delete it from here as well. For the time being, let it be here as well. So we have defined our region of interest. Next thing, what we need to do, we need to get the images from where the images will come up. So for that, as I have already said, from the search bar, from the data search, you can also get that from here as well. But for the beginning purposes, I will go for the main website, which is there. That is Earth Engine catalog. Okay, you can just type Earth Engine catalog, and this will be there. Earth Engine data catalog. Just click on that, and there are thousands of data sets are there, particularly. So you can go for all tags or view all data sets. Or here is particularly as we will be working with Landsat. So there is a Landsat option as well. So just click on the Landsat, and you can see Landsat 9, 8, 7, I mean 1 to 9. All the Landsat data sets are there as well. On Landsat 8, which is time duration is 2013 to is already present in present time as well. So if you just click on Landsat 8, these three types of data, as you all know, raw images, TOA reflectance, top of atmosphere reflectance, and surface reflectance. Three types of images are all there. Okay. So whatever you are, feel free to use that. But you know, surface reflectance will be all radiometrically, atmospherically, and geometrically corrected images. So I would suggest to use the surface reflected images as, I mean, say, for the analysis purposes. Anyone can use other two as well. So just click on surface reflectance, and this option will come up. And from there, you will see Google, that is Earth Engine snippet. This is the image code, which, or we can say image ID, which we require. And this ID stores all the Landsat images, all the Landsat surface reflectance images of Landsat 8 particularly. All the images all over the world within this ID. And that is stored in the Google Cloud. We can access it by running this code. And the date availability is also there. There is the brief description you can read. There is the band information, how many bands is there and which band is representing what. Okay, you can see the bands names are like SR. SR is for surface reflectance. Band 1, band 2, like that, band 7. And other things is also there. So we'll be focusing on optical bands part only, right? As you already know, these are the optical bands. And I will come to the scale factor and offset factor a little bit later. So what we're going to do, we will just copy this code, copy this ID, just select and copy, and just go to our Google Colab, and let's say we are writing a variable, say Landsat, naming a variable Landsat and Control V, just copy it ID. And in this variable, we have stored all the Landsat 8 images. So I guess you all have downloaded and worked with images from the USGS Earth Explorer. So there you need to filter the images. Basic filtering techniques you need to use, right? To search your images. Here we do the same things. So what is the first filter we want to do? We want to do, as we have drawn a feature or region of interest, we want to filter images based on this region only. Okay. So what we can do within this ID, we'll use dot filter bound. Filter bound B capital bounds in filter bounds, B is capital. Whenever we work with any earth engine method, this is called a method. There, the first letter will start small and second letter without any space will be in capital letters. This is the basic funda. So we will use filter bounds, and within curve bracket we will define this variable as we have defined ROI. We will specify that one ROI. Okay. So this filters the Landsat images based on this reason only. You can run this code. This code is run and nothing is shown. So one thing we can do, we can just call that variable to see how many images are there. If you just run that variable Landsat, so if the number is high, this will take time, not even not too much time. You can see the time is also show in the right bottom corner. I guess something 400, 500 images will be there, maybe more as well. If it is gone more than 500, there will be error. So total number of images for this region, you can see count 487 images. Okay. You can just, there is a drop down menu, expand. Okay, as the number is very high, this drop down will is taking time. So let us filter down some of the things in little bit more. And another thing, what we filter the thing based on our date, whatever time frame we are specifying. So that filter we can use filter date D capital. Sorry. Filter date D capital, and within bracket we will specify start date. There will be start date, comma, end date. Okay. So how the start date and end date will be specified within code. And this format will be year. First of all, you need to specify year. For example, we want to filter all the images of 2020, let's say. So start date will be 1st January 2020. Month, then day. And end date, as the logic says, end date will be 2020, 31st December. Sorry. Twelve 31. So this will filter all the images of 2020. So basically one thing you need to remember, the last value or date which we specify, that doesn't include, that exclude actually. So whenever, if we use 31st December, it will take 30 December, up to 30 December. So actually if we want all the images, so this you need to use as actually 1st January 2021. So this will take all the images of 2020. If you run this code and see how many images are there, I guess 30, 40 something images will be there, 41. Okay. So you can just expand it, and there is a called features, 41 elements. There is a list of all the images, and in the name, this is the image ID of each and every image. And image ID, also you can read it from here. 138 is the path number, 045 is the row number, and this is the date of that particular image. 2020 year, month 1, date 1, 1st January image is also there. So particularly to see the image property, you can expand each and every image and see the properties. There is the image properties associated with that. But one thing you can do, if you just want to see the image property names, what we can do, so we need not to visualize all 41 elements. So we can use a function or method dot fast. What it will do, it will just display just fast image of the collection. This is the image collection, and now this has become an image or simply the fast image. And this expansion will be easier. So you can just expand the properties, and you can see all the property names over here. One of the specific property which you always see, what? Cloud cover, right? So we always want to filter our images based on cloud cover. So this filter also we need to specify most of the cases. And you can see the date acquired, in which date the image is acquired. There is also another option in Landsat. But these things are generally not there in other satellite or other data products. So mostly the date or time information, you can see there is the start time and end information. Okay. So, and what is the thing in this RBI? I guess maybe you are seeing for the first time, then time is something like this. This is nothing but in milli. Sorry?
in millisecond. I
Sorry?
said this is in millisecond.
I couldn't hear you. Are you saying this is in milliseconds?
Yes, yes.
Absolutely, absolutely. This is milliseconds, and from where? From 1970, 1st January, the millisecond has been counted. So you can just check it. Let us check here. Just copy that number, and I have opened an website which will just epoch converter. It will just convert, and current time is also showing current millisecond just running. I will just paste it here, and let's say transform to human date. It is already saying 1st January 2020. Time is also saying in this is the time in IST, and UTC time or GMT time is 4:31:37. You can see that. And date, we have already confirmed that over here there is also a date information, date required. So particularly we are focused with the cloud cover. So we can just copy this property, Control C, and filter it. Filter it based on cloud cover. So how we'll use dot filter within bracket EE dot. Now filter is F is capital. Whenever use EE dot anything, everything comes with capital first. First word is capital. When is there is something called EE dot something like this, EE dot image collection. I is capital. Okay. So EE dot filter. Now dot will say LT. LT is nothing but less than. And another option is there LTE, less than or equal. Similarly, you can use GT for greater than or GTE for greater than equal. But for cloud cover, we will prefer LT less than or less than equal. So within less than equal, within code, we will use that property name which we have copied, cloud cover, and outside quotation, we giving a comma, we will specify what is the percentage of cloud cover you want. I mean, say less than what percent? Let's say generally we use 5 to 10%. Let's say we are using 10% of cloud cover images, and simply run this code. And again, just let's say we are removing fast to see the number of images. Last time it was 41. So now the images is there only 12 images. Okay. And to see the images, what we can do, to how to visualize an image, I will go for that a small bit. To visualize an image, what we can do, we can use the variable map which we have defined. Map. Another important thing you are seeing already, the Google Colab. As I'm writing, completion in the prompt it or may not be. So what we will do, we will use map.add layer and the Landsat image I will take and only visualize. We are just making it blank dictionary. Okay. no visualization parameter. And then we can give a name, let's say FCC. It will not come as FCC, but we will do.
Can you hear me?
And yes,
Yeah, actually, we couldn't hear you properly. The last step, what you have done. So kindly, can you repeat it, please?
sure. Which step can you tell?
The last one, this.
Up to which one was clear?
Actually, the map at layer section is missing.
Okay, sure. I will go for that one. Now the voice is clear.
Yeah. Now, okay.
Okay. So how we can add a map? We can use map dot add layer, and within simply we can call the image we want to visualize, but there is 12 images. So for the purpose, we can just visualize the first one and comma, then we need to define a visualization parameter, and it is also auto completing. So we will not use that for timing. Define. And last, we can just name the layer, say layer name. So let's say we are naming it FCC, and with code, this has to, if you just run this code, okay, the Lancet name is wrong. And another thing you can see that as I have made an error, there is an option called explain error. So if you just click on that, the Gemini will open up. So it is saying the Lancet is not defined. I get autocorrect me for that it is the spelling mistake. It says, you can see, it has autocorrected me that your spelling was wrong. So this is also an important features of this Google Colab. Just run the, but image will be completely blank as we haven't defined any visualization parameter to it. So for that reason, manually we can change it from here. Just beside HCC, there is a setting options. You can just click on the setting and a window will pop up. From here, you can specify the times. As you know, bands, which band is which, band 5 is NIR to commission. And another thing we can see, the range, custom range is always 0 to 100. So we can change it, for example, let's say 90%, 100%, and this will see. And just hit on apply. The images will come up. Okay. So I am not going into that part as of now. So what we can do, next thing, what we can do, what will be our step to get the shoreline.
Sir, please.
Hello.
Sir, could you please once again repeat the process of image visualizations? Hello.
Sure. Is my voice clear?
No, sir.
Is my voice clear or not?
No, sir.
Yes.
Okay, just let me just give me
Your voice is not clear.
You do not have a stable connection. Please look into it.
now. Is it clear? Or is it also
Yes,
again
it is
cracking my
fine.
voice?
It is fine.
It is fine.
Now is better. Clear.
Okay. Oh, sure. So during visualization part, what we are doing, as we have already mentioned the variable map, this map is nothing but this base map, which we'll use to visualize. And for that reason, we will, if you used anything for this variable, let's say you have used x, not map, then I would call here x. As I have mentioned map as the variable, so I will call the map and use add layer. And within bracket, I will call the image which I want to visualize. So here the images are in the Landsat, but the thing is there are 12 images. We cannot visualize 12 images. So I will just show the how can we use the first images. So we will use dot first method and just give a blank visualization parameter. You can define it as well. And then we will name the layer what name we want to visualize, by what name actually. So let's say we are calling it FCC within quotation. Okay. And if we just run this code, and the layer will be visualized in your map like FCC. But the thing is, this thing is completely shown as black. So you need to just click on the setting. In the just beside FCC, there is an option called settings option is there. So as image is large, it is take time. So based on that, as Landsat 8 has red NIR band in 5, red in 4, and I mean say green in band 3. So based on that, we can arrange the band as 543, and stretch by default the stretch value is from 0 to 100. That is, it is by default thinking all the thing whatever you add in the Google Earth engine, it will think the lowest value is 0 and maximum value is 100. If you don't specify, you can just change it from here, for example 100% or anything. Let's say I'm using 90% of stretching and apply, and you can visualize the image like this. And just you can close this window as well. So next thing what we want to do, we want to just extract the shoreline, right? So just a basic thing, what is the shoreline? Generally, this is a image taken by me in the Sundarbans. So as in the image you can see, there is I can say
Again, there is some issue in network.
you can see that there is a white portion,
Sir,
high
your
water,
voice is not
high
clear.
somehow.
Hello? Sir, your voice is breaking again.
Okay. Hello, is the voice clear?
Now it's clear.
Yeah, now it's clear.
Okay. Okay. Sure. So what I was saying, the how shoreline is being defined, like many things we use. One of the thing is high water line, or how much water used to go in the high tide time, and another thing that is the low water line, the lowest tide that can be happen, and many more researchers use the vegetation line as well. The I mean say the shoreline. And for particularly for this purpose, many in the context of remote sensing, as we are taking the images for the images, satellite images, we use the instantaneous shoreline. What is instantaneous shoreline? The instantaneous land water boundary, whatever water position is there in the time of the image taken. Okay. So we will be taking this concept of instantaneous shoreline to see how we can extract the shoreline from here. So what we will do, we will use an index, and in the meantime, you can see how can we use index. So here, I guess all of you know, one of the prominent land water index is normalized difference water index, which uses green and NIR band in this formula form, green minus NIR by green plus NIR. So like that, we can use this thing to create an NDWI image. Let's say we are defining a variable NDWI. Okay. And for that, what we can do, as you can see, there are 12 elements in the images of a year. So if we just take all the images and average out, so there will be minimal effect of tide in that cases. One thing you need to understand, that whatever shoreline we are taking, that is the time of the image taken. That may be some of the images may be in the low tide time, maybe some of the images may be high tide time. So that will not reflect the actual position, or we can say the changes what is occurring, but essentially due to erosion or deposition, right? So that tidal changes need to be suppressed. One of the techniques we can use, that is just take the mean of the all the images in that year to minimize, or you can use the median as well. So let's say for this example we will use the mean. So for the Landsat, we are taking the mean of all the images by using dot mean function. Okay. So the 12 elements or 12 images will be covered in single image, and just take it dot normalized difference. This things is auto completing already. For auto completion, you can just click tab on your keyboard. Clicking tab, the thing will be auto completed. So what you need to do is dot normalized, and within this you need to create a list. A list is created through the square bracket, within a square bracket, and within that you need to specify both the bands. Here the bands are green and NIR. So first band will be green and second band will be NIR. And this normalized difference method will calculate that formula. So here we already know band 3 is green band and band 5 is NIR band. So we'll make this NDWI image, and you can just run it. And if I want to visualize the NDWI image, again, we can use map.addLayer. There is already a default code. How can we use map.addLayer? Let's say we are calling NDWI. And again, I'm not going to define here the visualization parameter. Sorry. And just name the layer as NDWI and run the code. And a NDWI layer will come up. So as the region already also covered this side of image, that has also came up. You can just again click on that and change the custom visualization parameter. Let's say to sigma, to standard deviation is nothing but. And you can see there is already a distinction between land and water boundary. Okay. Another thing what we can do, there is the called clip function. So as we don't need all the big images over here, just need that small portion of our study area. What we can do, we can just use dot clip, and within clip we will specify our region, that is ROI, and again run the code, and you can just add layer again. So it will just it will have the NDWI image for this region only. Okay, so that visualization we can just change again. If the previous visualization window is open, you need to close it and again open it from the last one. And let's say we are switching to yes.
Hello, sir. Sir, could you please explain once, the last step that
I clip thing or NDWI thing? What was there? From which step are you asking? From NDWI or clip?
No, sir, last part. I mean, coding part, where we are selecting our area of interest. Uh,
We are not selecting area of interest over here. We have already drawn that in the previous steps. So what we are
yeah, no,
doing,
I'm
I,
not.
I, I think she might talk about this clipping part, the how this.
That's.
Yeah.
okay. As in the last time, what we have used that this clip thing was not there. Okay. So there you can see there is a big image was displayed. So you just don't work with that and you just don't want to visualize the large image and which will take time as well to load that thing. So if you are just using on a small area, so what is best is use clip method. So every method is start with dot. So you will just dot and write clip and within curve bracket just specify the region you have drawn. The region we have already drawn and stored in ROI variable. And we are just calling that ROI variable within clip method. Okay. And if you just run it and just again, just for visualization purpose, you can add it and see the images. Okay. And from the settings window, you can change the visualization parameter to better understand and hit on apply. So to look for the greater contrast between land and water. So one of the thing what you can do whenever you are working with one single image, the best thing you can do is that go to the toolbar and use inspector tool, the first tool, that is the eye tool. Inspector tool, just click on that and this option will came up. As we are working with pixel, the pixel is good. So you can just click on the pixel and look for the values what is there, for example. So if you just click on try to click on the edge of the pixels and it is showing that is particularly 0.05. So you need to get a threshold value. What value particularly you can differentiate land and water basically by which value. Okay. So which you can just, if you are working on a single image, you can just click on the boundary portion, which you can identify and that use that value as a threshold to classify. Here the thing will be that binary classification of land and water. So first of all, what we will do, binary classify the land and water based on a threshold value. The value will be whichever you decide based on that. If you are working on a single image. But one thing is good for NDWI is that it works, I can say good, not better, but good with zero threshold value. Theoretically, zero is the threshold value for land and water in NDWI. But practically that doesn't happen. But NDWI fits good with that value. So what we can do, we can use a threshold value to make a binary image. So let's say what we have checked, let's say our threshold value is, for example, here is 0.03. For later stage, we will use just 0 when we will work with multiple images. So here, let us use 0.03. And water will be greater than this value and land will be less than that value. So what we can say, let us make a binary image, binary, let's say binary a variable, and take the NDWI and use GT. GT is for greater than, or you can use GTE greater than equal and use that value 0.03. This will create a binary images of land and water. Okay. And if we just want to visualize it again, map dot add layer binary, comma, similarly, I will keep the blank visualization and let's say name binary. One thing you can do, if your previous map is way up, you can again call the map again by just writing map and giving enter. Your map will be also there as well. So you can see there is the binary images is there. Clearly, you can see a distinction of land and water with just simply value 1 and value 0. One is 0 and one is 1. So that thing we have already done. So what we need to do is next thing, that is the raster form, right? So we need to convert it to a vector. So to convert a vector, what we can do, we can again make a variable, let's say vectors or vector, anything, XYZ, you can name any variable. And we will call this binary image and use a method called self mask. Again, M will be capital, but what is self mask? It will mask out whichever is not zero. For example, here the zero, you can again just by color you are seeing one thing, but if you are not satisfied, you can just again inspect by eye tool, taking inspector, what value is it? If you just click on black, so black portion, the binary value is 0. And if you just click on the land portion, sorry, water portion, binary value is 1. So it will mask out the non-zero values. So here the non-zero value is 1. So using self mask, it will make particularly it will take on keep only one segment, black portion or white portion, that doesn't matter. We only want this boundary to a black and white boundary, land on water boundary. To get that, we need to mask out or remove one of those part form. Maybe it is white or maybe black. That thing will be done by self mask. So first of all, we will do the self mask and again use a method called reduce to vectors. We want to convert it to vectors, right? So again, reduce to vector, T capital, V capital. Reduce to vector, and within this particularly we need to specify 2 arguments. There are many more arguments, but specifically these 2 has to be mentioned. One thing, the geometry, that is the region over which you are working with, or you want to reduce the region, convert to vector. That is, for our case, this is Ry. Okay. And next thing, what is the scale? That is the pixel size or the resolution you want to work with. Sorry, scaling is wrong. Scale, as we are working with Landsat, we can use it 30. Its default unit is meter, so no need to mention that on. So scale is 30 meter. Just mentioning that, you can see, okay. So it is meters. Okay, so that is not vectors, actually that is reduced to vectors. So that error was there. So if you just run this code and see the vectors or what is the features is there, you can see it is saying 6 elements is there and it has made a feature collection. You can just remember in the first step we used with working with an image collection, multiple images there. And now we are in a feature collection, that is vector, that is multiple vectors is there. But you can say that we are working on a one image and one boundary should come up. Why 6 element or feature collection is there, right? So for that, let us visualize the vector. Map dot add layer. And similarly, we'll just take the default, say blank visualization and add the vectors layers in the map. Just let me close other, let me switch off other images. Okay, you can see that vectors part is already there and this is vector is polygon vector. Okay, so there is a big one which we wanted, and this portion will be its boundary. We will see how can we extract that part only also. And as this was also water according to the get function, so this has also become, this small portion has also become some features. So in total, it has got 6 features and you might be interested to remove these features. Okay. So one thing what you can do, if you just expand this feature collection thing and features and just expand properties of any features, you can see there is a called count features that will be automatically incorporated when you just convert to raster to vectors. That means 2. It says it has only 2 coordinates. Geometric coordinates, it has only 2. You can just again go to there is 3, And if you just go to last one, there are many more vertices. See, 673 vertices. So one thing, we can use that count function, count property to filter the vectors. So what we can do, let's say we are redefining vectors with filtering the vectors. We can redefine, as vectors variable was already defined, and we can also redefine this, or you can just change it to another name as well. That doesn't matter. Let's say filtered, if I filtered underscore vectors, let's say name it like that. So in that, just like we have used filtering in cloud cover, similarly we can use filtering technique here in as well. So what we will do, e dot filter with F capital, and use what we want to use, the count. So we can use here the greater than function, and let's say you can see here, let's say the bigger one will be more than 100 or 1000, I can say. So by trial and error or just visualization, you can just decide how many threshold we can give for this filter. Let's say I'm giving 100. So filtered vectors will be based on 100, and less than that will be removed from these things. And if we just run this code, sorry, okay, there was a missing. What we need to mention, what property? The property was count. So based on property count, we are filtered. And if we just now visualize filtered vector, you can see the small portion has gone. Only the bigger polygon, particularly which you are interested, that's remain. Okay. And again, you can also see the number of features. Just writing filter dot vectors. And one thing is sure, that it will be always a feature collection, not feature. So, but it has only one element. That is only one polygon which is there. And the last thing what we are really focused on, to convert this into a polyline or line features, as this is a polygon features, and remove, not just simply we just want to convert this line, particularly we want to keep this line, not other line, that shoreline portion. This is our ROI boundary, right? This was our ROI boundary, this last line portion. Particularly we are interested with this portion of line. So that thing we need to do. And for that, we need to see for another concept, how to work with an image collection or a feature collection. Whatever I have done till now, that was completely with the working with, I mean say image, particularly one image. Let's say here binary was only single image, right? In the NDWI thing also, we used Landsat.mean. We didn't use all the 12 images individually. We used .mean to make the images a single one, and then use this normalized thing. So in Google Earth Engine, what is there? You can also see there are many more things for e.feature, e.feature collection, e.image collection. There are methods which work only on image, and there are methods which directly work on image collection. So for that, we need to go around. For example, this normalized difference method doesn't work on an image collection directly. I mean, let's say we want to use it for all the Landsat images and remove the mean function and try to do this. There will be an error. It will say image collection object has no attribute named normalized difference, because this is not an image collection attribute. This is an image attribute. For that reason, we need to go around. Same thing what we will have to do regarding these things whenever we are working with, I mean say vectors. In that case also, you cannot use that image collection directly, feature collection directly, as there is only one element, doesn't matter. But the, I mean say property, or the, I can say it is a feature collection, not a single feature. Its attribute is there. In that case, we need to define a function to reiterate all the steps. We need to reiterate. I will just show an example how we do this thing, define a function. Then I will come to the how to convert it in the line. Simply first, let me go. Say, let it be mean as it was. Okay. Let me just show you how can we calculate the NDWI for all the 12 images that was there for with us. Okay, simultaneously, and the resulting NDWI image will be of 12 NDWI, not a single. So for that, what we need to do, we can define a function. And how a function is defined in Python, we use def. And we need to give the name of the function. Let's say we are naming the function as NDWI. This is the function name. Okay. And within function, within bracket, we need to define a variable. Or you can have multiple variable as well, which the function will take as an input. And let's say we are naming it variable as an image. You can write X, Y, Z, Y, Z, or anything, doesn't matter. Let's say we are taking image as a variable for this function NDWI. And this statement ends with a colon, and you need to go to the next line always. And there will be an indentation. You need to keep that indentation as well. So within this function, we need to define NDWI. Okay, so what we can do, let's say, let define the function with different thing. What we can say, let's say binary. We will define all the things in similarly. NDWI and binary will say calculate in the same function. So within that, we can define a NDWI image, NDWI multiple image, and NDWI is calculated as. Now things will be similar. Normalized difference. If I just take this and let me delete. So this part I was talking about image.normalized difference. Okay, now image is the image. We haven't defined it yet. We are defining function, and within function, the image will be reiterate again. And first image will come, then first NDW will be calculated, the second image will come, and then again it will be calculated. This thing will carry on. Similarly, and the last step as we have done, along with that, we can use the click function, as click function also doesn't work on image collection. This is an image attribute. Now you can return the image. Every function needs to return a value or a variable. Okay. So what you want to return? This. This will be calculating NDWI, but you want to return something. You want to return maybe, as my function is binary, we just want to get the binary image. So binary image, how we calculate it? NDWI greater than. Now let us, I don't know what is the particularly good value for all the 12 images. So let us just use good default 0 value. So we can use that return NDWI get 0. So this function has been defined. Sorry, this function has been defined already. So you can just run this code. And now the function is defined, but this function is not taking any images from the Lancet image collection, the 12 images. So how we need to define that? Now we will, this is called in Earth Engine, this is called mapping. And mathematics also, that term is familiar with, that we reiterate the same thing over the all the images. So let's say we are redefining these binary images. Not say, let us define another variable, otherwise it will be confusing. Let's say we are defining land and water as a variable to have all the 12 binary images. Okay, so for that we'll call the image collection Lancet and use map method. And within map, we will define the function, we will specify the function which we already defined, that is binary. And this code will have 12 binary images. As we have skipped the step within that, that two step has been done simultaneously, NTWI and binary thing. Okay. So here you can see number of images, land, water, sorry, just call the land water. And you can see this is also an image collection, and all the things are binary images. And you can just visualize uh, images based on it thing what you want to visualize, but we are not going to visualize again for it. Next thing what will go, that the vectors has been done, right? Again the vectors, this is a simply working on a binary single image, and the method that reduce to vector, this doesn't work again on the image collection, this work on images, single image. So if we just want all the 12 images, to be in a single, I mean say to convert it into vectors simultaneously. So in that case, you need to define a function as well for this purpose. So for that, what we can do, I guess we are getting how we used to define a function, right? So for what we can do, let's say we are defining a function called vectors, and vectors will take input as an image. And what it will do, let's say we are defining a variable within this, just vectors. Function is vectors and the variable is vector. So vector, what will do? It will take the image. Again, same thing. It will within function, things will be same. It will self mask dot reduce to vector geometry dot ROI scale 30. This will be same thing. The thing is here we are defining a variable within function image and it is taking input as an image. And when are using dot map, this means this Lancet thing, first image of the Lancet is being inserted over here, then is calculating. Then again, next image is being inserted over here, then thing is calculating. This is how this works. And same thing, as we said, self mask dot reduce to vectors. And within that, we know the two default mask parameter, geometry and ROI will be given. Okay. So this similarly, this function has been defined, but this hasn't taken those images in the land and water. Okay. So let's say we are defining another variable called boundary. And again, we will map it. Okay, so all the images in the land and water. So we'll call land underscore water and map dot map, and within bracket the function we have defined, that is vectors. You can run this code. There is a problem. So there must have some blank thing. So here one of the thing there thing is, let us see if this work or not. Then I will spelling pattern. And step marks. There must have some blank cells. Just give me a minute. Let me see what is okay. There is nothing in vectors as of now. I have already made an thing, repeatedly thing also there. We can use another thing. Maybe if there is a pixel issue, we can use maximum pixel as another optional attribute. By default, if the pixel is greater than how much it by default it can generate, there can be a problem as well. So we can use that one as well. 1e15 is nothing but 10 to the power 15. This is nothing but 10 to the power 15. This means, let me see if this works or not. Okay, let us see what our Gemini says. We can always use this one. There must have some blank thing, and it will suggest me some changes. Oh, sorry, that was my mistake. Every function, this is a function, but point is maximum pixel. You can skip it or just, I mean, just state the function must return something, right? We have not written that code, so it will have return. What will it will return? Just we just want to return the vectors as of now. As of now, we can further add another thing. So if we just run this vector and now map it, so all the bound vectors has been created, and if you want to see how many things are there, you can see there are 12 feature collection, and within features 12 elements is there. One thing problem is there, you can see there are all the things have 0 elements. System index is there, all the things have 0 elements. That problem arises due to a problem that is called feature collection of features. As now we can see the boundary features will increase. 183 has been got, but there are many polygon, multi-polygon is there, but nothing is blank. What does flatten does? Flatten does whenever using, as I have already said in the last thing, that whenever we are using single image, right? Here we are using single image, but it also give us a feature collection. Now, if you think, if you are working on a multiple image, what it will give? For each image, there is a feature collection. So there will be collection of feature collection. We don't call it collection of feature collection by name, but this is actually a feature collection within feature collection. So for that reason, if you just map this thing, the thing will just couldn't read. What flatten does is it reduces the feature collection of collection into a feature collection. Like previously, you can see there was 12 element. Now it has flattened. Now the vertical structure has been, horizontalized, and 183 elements has been now has been there. So by flatten, you can just reduce the boundary into like that. And one thing, as last thing also we have done as filtered, as there will be some unwanted polygon also there, which we don't want. So we can use the same filter method. You can just copy it, and we can use it in the return also. You can just filter it and define the vector. So the filtering will just reduce the boundary, and just again rerun the code, and now see it will just reduce. Now it has some 17 elements. Ultimately, it has to be 12 elements, but there are some features as well which are greater than 100. But you can say there are 5 elements which are just greater than 100. Okay, you can just keep it with that, or you can just visualize it to see how many is there. Or whenever you are exporting that, you can work with that in that time. Okay, so we will just look for last step of today, that as we have already seen how to convert a vector, already we have seen up to the polygon thing and filtering thing. Last thing what we want to do, we want to convert it into a polyline. Okay, so that will be last step, and then we will take the questions, whatever question you will have. So what we can do, again, as we have said, we are working with a feature collection. If you working with a multiple images, then also you will get a feature collection. If you work with a single image, then you also get a feature collection. So for converting into line or polyline, you need to define a function. So let's say we are defining a function called polyline. And within polyline, let's say we are considering a variable called feature. And what this feature will do, first of all, what we need to do is we need to extract the coordinates. Every information, everything in this polygon is nothing but those coordinates. Different coordinates are there. So the coordinates we need to extract, and coordinates, let's say we are defining a variable called quartz. For quartz, from where the coordinates we need to extract this feature. Okay. And for coordinates is there in the geometry. Geometry of the features has the coordinates. Dot coordinates. I guess the spelling is wrong. And just close the bracket. So all the coordinates of the feature will be stored in the variable quartz. And another thing we need to do, we will do is define a buffer distance. What we are doing, I'll just explain. Distance. How the buffer distance will be defined? E dot number 30. Why we are using 30? 30 because 30 is the resolution of the images. And E dot number converts this just number into an Earth Engine number. Because every command is Earth Engine, if you just write 30, that Earth Engine wouldn't able to read. So we need to convert it into the Earth Engine number by using E dot number 30. If you are using Sentinel 1, you can use Sentinel 2 multispectral image, you can use 10 as a special resolution. Even 3010 is okay. If you just, I will say what is the logic behind it, then you will understand. So next we will dot multiply, and we are multiplying with a -1. What this -1 does? The value will be now -30. By buffer distance, what we want to do, we want to create a buffer around this polygon, right? But if we just think, we are taking a buffer of 30. Just think there was no -1, just we are taking a 30-meter buffer. Simple GIS thing. If we just taking a 30-meter buffer around it, the thing will cover that. But whenever using -1, what it will do, it will take, it will take within buffer. We can simply just around buffer and within buffer. The buffer will be 30-meter inside. If you are just using -1. Uh, I guess I have removed the ROI thing. That if that would have been there, would be better to understand. You can just imagine the ROI was in the land side as well, right? ROI boundary. So what we are going to do is we are going to take a buffer inward of ROI. By doing so, let's say ROI was like this. Okay. I'm just taking an arbitrary thing. This ROI will not define to just make you understand. Something like this was there, right? So what we are trying to do is we are taking a 30-meter buffer inside ROI and intersection. You know what intersection does in GIS? If we think a 30-meter buffer and this boundary, this last boundary of the vector polygon will be the same as the ROI boundary of the last thing, right? Because ROI was boundary was same or as of that one. But this boundary is what we have made through the processes, all the processes we have done. So by taking inner buffer, what we are doing, we are ignoring this part, right? This part will be within the buffer. But this last portion along the waterline, this will be opt out. If we just intersect it, let's say the buffer is kind of, okay. Let me just go for a buffer. Sorry. After taking the buffer, something is like this, let's say. In buffer we are taking, right? Just for example, I'm showing this portion only. So after taking the buffer, as the ROI, original ROI is bigger in the upper portion and the lower portion, that was same as this line, black line. After taking inward buffer of 30 meter, this thing has happened. Now, if I intersect this vector with this buffer, what things will remain? You can see this line will remain only, isn't it? The coordinates of this line. So that was the logic. That is the logic we are going to apply here. To remove the unwanted line, to define a buffer and to get the coordinates. And what the function will return? We need to return a function. So it will take the feature and set geometry. Set geometry G capital. What type of, set geometry, and what type of geometry it want to set? There is not any name called polyline. That thing, it will be multi-line string. Sorry, this there is a, I mean, miss. You need to first set, and within set, what we want to set? E dot. Sorry, I am just forgetting something. It's not need to memorize everything. Okay, that was the code for the reference. You need to apply the set geometry first. Within the multi-line is. So the thing is set geometry, and what geometry we want to set? E dot geometry dot multi-line string. Multi not point. Multi-line string. And what is that multi-line string? That is based on those coordinates which we have extracted, right? Now, if we just keep it like this, if we now just keep it like this, what it will produce? All the lines in the polygons, but we don't want all. What we want? We want to intersect. We want an intersect of the thing. What intersect? The code is completed. Intersection of ROI. As the ROI was drawn before, and we want to do a buffer around that with a buffer distance, particularly in inward buffer, as it's minus 30. Okay, these things it will return. So that there will be a single line. Okay, so if we just run this code, I will visualize the single thing which we have done last time. Where was that? This filtered vector. Okay, these things will run fast to visualize, because multiple vectors you wouldn't visualize for a greater thing. So let's say we are just rerun this. Okay, let's just run this vector again. Okay, we need to define NDWI again, binary again. I'm doing vector. And filtered vector, and we will use this filtered vector to convert this polyline. Okay, let's say we are defining a variable shoreline, and we will take the filtered vector dot map polyline. Okay. Okay. So what is the problem? I can just check it out. Okay, the multiply spelling was wrong. Anyway, multiply. So just run it again and run the shoreline thing. You can check how many shoreline is there. Obviously, there will be one, because our input image was one thing. There was one, and you can just visualize it. Map dot add layer. Just call the shoreline again. You can just keep this. Let's say we are same. Just making the visualization blank. Which is shoreline, and again calling the map here. So we can just close other one, and we can see there is a single line. Obviously, there is some zigzag. How we can manage that thing? We'll take it in the next class, and how we can export it in our desired format, that will take up in the next class. And then we'll go for the shoreline change analysis.